multiplying a fraction by a fraction. Today we're going to look at first a part of a part. So in our example problem here, we have a part 1/2 times another part 2/3. And we're going to use the brownie pan method just like before. So we're going to start out with 2/3 of a brownie pan. The 3 in the denominator tells me that I divide this into 3 parts, and the 2 in the numerator tells me that I'm shading in 2 of those 3 parts. So my brownie pan is 2/3 full. Now I need to take half of that. So I'm going to divide now in the opposite direction and divide my pan in half. And you'll notice my blue shading here represents half the pan, but my double shading represents half of 2/3. So how many pieces here are double shaded? There's 1, 2. Out of how many total pieces? So remember, the pieces have to be the same size. So if I look at the same size pieces here, I have 6 of them in the entire pan. So my answer here is 2/6. Now you might have noticed the pattern, and we've talked about this in class, is that I can simply multiply the numerators by each other to get my new numerator of the answer. 1 times 2 equals 2, multiplying the numerators. And then I can multiply the denominators, 2 times 3, to get 6 and get my answer. That is an algorithm that you can use to multiply fractions. The area model here just shows you why it makes sense. So remember, you're multiplying everything in the top stays in the top and everything in the bottom stays in the bottom. The question then becomes will this always work? So let's take a minute here to think about that. We're going to look at multiplying a mixed number by a mixed number. So now what do we do here if some of our numbers aren't in the numerator? The first thing that we're going to have to do is we're going to have to rename those mixed numbers into improper fractions. So how do I take 2.5 and make that into an improper fraction? Well, here's 1, here's 2, and here's a half. So how many halves do I have here that make 2.5? You'll see we can count these pieces up. 1, 2, 3, 4, 5. I have 5 halves. 2 halves make 1 whole, 4 halves make 2 wholes, and I have an extra half here. So a total of 5 halves is equivalent to 2.5. How do I turn 3 2/5 into an improper fraction? Well, here's 1 whole, here's 2 wholes, and 3 wholes, and an additional 2/5. So how many fifths make up 1 whole? There's 5. 5/5 make 1 whole, 10/5 make 2 wholes, and 15/5 make 3 wholes, plus 2 more. I have a total of 17/5. Now I can rewrite my problem as 5 halves times 17/5. Now I'm ready to use that algorithm. 5 times 17 is equal to 85, and 2 times 5 is equal to 10. Now I've got an improper fraction as my answer. I want to now convert this to a mixed number. How many times does 10 go into 85? 8 times with 5 left over, or 5/10. Okay, so we had a remainder of 5, that becomes 5/10. And I can rewrite this and simplify it as 8 1/2. So that is one way to multiply a mixed number by a mixed number. Now we have a second way we can think about this, and we've done this in number talks in class here. It's using this area model, or what we call the distributive property. The thing that you want to remember is that you're remembering to multiply all of the pieces. So in our number talks, we talked about splitting up numbers into numbers that were easy for us to add, subtract, multiply, or divide in our head. So if I have 2.5, I can write this as 2 plus 1/2. If I have 3 2/5, I can write this as 3 3/5 here, and turn this into an area model by splitting up my rectangle into now 4 smaller rectangles. So multiplying the whole numbers, that's pretty easy to do. 2 times 3, that gives me 6. Then I need to multiply 1/2 times 3, so half of 3 is 1 1/2. Then I need to multiply 2 times 3/5. Remember, I can write a whole number 2 as 2 over 1. So I can still multiply across. I get, that's 2 fifths there. I get 4 fifths. And then 1/2 times 2 fifths is 2 tenths. Now all I have to do is add up the area of each of these 4 pieces to get my answer. So I have 6 plus 1/2 plus 4 fifths plus 2 tenths. Remember, when I'm adding fractions, here is when I have to have same size pieces, so I have to have common denominators. So I know that 6 plus 1 is 7, and now I'm adding 1/2, which is 5 tenths, plus 4 fifths, that's equivalent to 8 tenths, plus 2 tenths. So my 8 tenths plus 2 tenths makes another whole that I can add to the 7, and I'm left with 8 and 5 tenths, or 8.5. So you'll see I get the same answer here. There's just 2 different methods of multiplying these mixed numbers.